And hello all and welcome back. It is time to move into three-dimensional. Now you think about it, length is a one-dimensional measurement. Think about measuring this line segment, and you literally would like to know just how many inches that line segment would be. Then of course we moved into area. Think about this triangle up here. How many square units would it take to cover that triangle? And of course there'd be parts of squares which you would have to add up all the portions. It's time to move into three-dimensional volume, and our focus for today will be rectangular prisms. Now I do have the homework assignment up from a day or two ago, so if you need, pause, come back when you're ready. Otherwise, we move on. Our objective for today is all about volume. Find the volume of a rectangular prism like this building over here that is 60 feet by 30 feet by 80 feet. Also, we're going to talk about composite figures, which is eventually where we're going. Many buildings, after all, are not perfectly rectangular prisms. Some might have a roof on the top, in which case you have more than one figure. So just so you know, sometimes we might have to add up one or more volumes. Sometimes we might have to say, well, there's a bubble in the middle, there's some part that is not needed, so we would take it away. But that's where we're heading. For today, volume of rectangular prisms. So we started with one-dimensional measurement. That would be the length of a radius, for instance. We went into two-dimensional measurement. That would be areas of figures. And today we reach three-dimensional stuff. Now, just to define volume, some of you might already realize this or know this. It is the number of cubic units that it takes to fill up a three-dimensional space or figure. So where if I'm looking out at my room, I might see yardsticks go across the room to measure the length of the room. I might see carpet tiles laid flat on the floor. That would measure, for instance, the area of the floor. But right now I'm listening to the heater running in our classroom. And really, to be able to heat a space, the heating technicians have to be able to measure the volume. If you could picture this, I know it's weird, picture cubes of air filling up the entire room. So they have to measure how many cubes of air are in the room to know how much capacity the heating units should be able to handle. So it's all about filling a space. Now, I do like to be able to start off with cubes, all right? So let's look at figure A, and I want you to keep the overarching question in mind, which box will hold the most cubes. All right, so we can start to build blocks bit by bit, level by level into this. Now, if you notice in this particular case, there appear to be 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 cubes in the first layer. Oh, it appears that there's another 12 cubes in the second. Total of 24 cubes fill that space. Now here, numbers are slightly different, right? We only have 1, 2, 3, 4, but then we have another layer of 4. Then we have another layer of 4. And then a final layer of 4. In other words, 4 fours, it would take 16 cubic units to fill up that box. One more time, let's go with this guy, which appears to be 1, 2, 3, 4 by 2. You guessed it, 8 cubic units. Another layer of 8. Another layer of 8, and ladies and gents, we have a tie. It will not be which box, it will be which box is. Both box A and C hold the same number of cubic units. But I wanted to show you that just so you picture cubes filling up a space. Think about ice cubes in a freezer. It gets a little tougher when you think about water like liquid, like pools. But think about filling a pool up with cubes of water. That's what you have to calculate in order to fill a pool. So as you saw what I did on the last example, I multiplied the length times the width, and then we added, or you could say repeatedly adding things is the same as multiplying. And here, ladies and gents, is our formula. Many of you may have already heard this. Length times width times height. Notice, ladies and gents, we have 1, 2, 3 dimensions. After all, volume is a 3-dimensional space. And so if you take a look at the example down below that we were just talking about, if we were to multiply 4 by 3, that would give us the 12 cubic units in one layer. But of course, we don't just have one layer. That's why we repeatedly add, or what do we call repeated addition? Multiplication by 2. 4 by 3 is 12. 12 by 2 would be 24 cubic units. Notice, 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 because again, we're talking a 3-dimensional space. You should have cubic inches, cubic centimeters, cubic feet, cubic units. Onward we go. Let's use the formula, where we now realize the formula of a volume of a rectangular prism is length times width times height. Let's go ahead and figure this out, where the length for this guy appears to be 3, the width for this guy appears to be 3, and the height, this is actually a perfect cube. 3 times 3 times 3, 27 cubic units to fill that volume. Over here we go. Write the formula. 1, 2, 3, 4, 5, 6 by 1 by 2 layers tall. 6 times 1 is 6, and then 2 layers of 6 would make 12 cubic units. Onward down here, write the formula. 1, 2, 3, 4 by 1, 2, 3 by 1, 2, and 3 levels tall. 4 by 3 is 12, but if we have 3 layers of 12, we'll get up to 36 cubic units. Now let's get away from the cubes and talk more about real spaces in this world. So here we are with a full of fiber cereal box perhaps. Write the formula. 20 centimeters by 10 centimeters, that would be 200 centimeters by 30 centimeters. Now I want you to notice something. 20 by 10 by 30 you're going to get. But again, notice you don't have to write the units I chose to this time. Think about centimeters times another unit of centimeters times another unit. Well, Mr. Cowan, anything times itself 3 times. There you have it with the cubic centimeters. So when in doubt, you can always write the units to make sure that your units are the appropriate number of dimensions. All right, let's talk about this aquarium. Length, width, height, 4 feet by 1 foot is 4 square feet, but now build that up 2 feet tall. Feet times feet times feet would be cubic feet of water. And last but not least, you might recognize this from what we did earlier. Length is 60, width is 30. So already we are up to 1,800 square feet, but now we have to build that 80 feet tall. Multiply 60 times 30 times 80, and you will get 144,000 cubic feet. If that is a building, heating and cooling technicians would need to know the volume of that building so they know how much capacity they need for their heating and cooling systems. Now we get to something that's a little trickier, and that is composite solids. Now, just like a compound in science class is a combination of 2 or more objects, think about water, has both hydrogen and oxygen atoms. Think about carbon monoxide with mono or 1 oxygen, carbon dioxide with 2 oxygens. All those are compounds. Why? Because they're made of 2 or more elements. In like manner, we have to be able to eventually cut up a figure and see that we have one big shape, the volume of this prism, another smaller shape, the volume of that prism. And if we want the total volume, we will have to add. Now, if it helps, you can pull that figure off to the side, just kind of envision what it will look like as two different shapes. Now I'm going to go ahead, I'm just going to draw this back in, and I'm going to notice if that's 14, then that's 14, then that's 14. If that's 14, then that's 14. If that's 14, well, I suppose this is a cube, so the little guy, length times width times height, will be 14 by 14 by 14. And if anybody was tempted to write 14 cubed, I commend you. That is the more efficient way to write that. Meanwhile, we have another, maybe I'll write big L times big W times big H, just to separate that. Now I can see very clearly that the height of this guy is 21, but the length and the width a little harder to figure out. What we have to do is we have to take this total length of 28 and split it up. After all, that side's 14, which means, okay, well, that means that side's 14. If I could, without upsetting you guys, pull that guy off to the side, we could see more clearly as well that if this width is 14, this width is 14. So now what we have is two different volumes, 14 by 14 by 21, 14 by 14 by 14, and of course we need to add them together to find the total volume of this composite figure, which is, sorry, I'm gonna write the answer down, 6860. And of course we're talking cubic feet as the final volume. So that is what I believe to be the challenge for the day, composite figures. When you have more than one figure, you have to be able to visualize, you could even redraw it. I like to write the formulas like this so you can kind of see a big volume, a little volume, and of course we needed to add these up. Now, sometimes you actually have the volume and you have to try to figure out different dimensions or just to find one missing dimension. So in this case, let's try to make a box with certain dimensions that would be 18 cubic centimeters. Now, I'll give you one example. So let's say, let me give you the lame example, not lame, but the least original of them. You could have 18 by 18 by 1. 18, excuse me, by 1 by 1. Now, of course, that doesn't quite fit what this box looks like, so let's come up with something different. What if instead of 18, this said 9? Well, you could have 9 by 2 by 1, or 9 by 1 by 2. But technically, that's kind of the same box. It's just a rotated box. So how about other numbers that'll go into 18? I'm going to stick to whole numbers. Obviously, you could do a lot of decimals as well. What about 6? Where you could have 6 by 3 by 1. There's a lot of different possibilities. If you want, pause the video, come up with your own. Come on back when you're ready to look at other examples. So one other example, 3 by 3 by 2, we could have talked about it. 2 by 9 by 1, we do have that one. 18 by 1 by 1. And yes, we could have split this up into decimals as well. That's only 3 possibilities. There's scores of possibilities here. All right, how about this guy? Where the length and the width are given, the height is not, and the volume is given. Well, you are welcome to write the formula down. And because the height is unknown, you know, Mr. Cowan, I like to circle that. But that means that every other dimension must be known in order for us to solve for that h. Well, in this case, length is 3, width is 4, volume is 48. And all of a sudden, we have an equation with one missing piece, and we know how to solve these types of equations. First thing I'm going to do is simplify. Why write 3 times 4 times h when you could simply write 12? H now, split it up. What would that missing piece have to be? It would have to be 4 inches tall. And that, ladies and gents, is how you use the formula to solve for one missing piece. It's kind of how we crank it up a notch from 6th grade to 7th grade. So assignment is a worksheet for today, assignment number 30. Take your time, do well. There are a couple of challenging problems in there. And we'll see you folks. Let's go.